Aspire is actually quite powerful when it comes to this kind of thing, using two rail sweeps, being able to use a shape creation, using our sheaths feature.
Hi, I'm George Vondriska of Vondriska Works in Hammond, Wisconsin, and I bet you have cut all sorts of stuff on your CNC router, but did you know that you can cut leather on your CNC router? This is about using a drag knife, and with a drag knife on your CNC, you can cut curves, you can cut crisp corners. Really, you can do anything in leather you would do with a utility knife, but with the benefit of using CAD in order to create your projects and the precision of a CNC to cut your projects. In this course, we're going to concentrate on toolpathing and understanding how to get the drag knife to do what you need it to do. That'll include using the drag knife gadget. We're also going to look at what you need to do to your CNC so that it's properly set in order to be able to use a drag knife and be able to cut leather here. This is all going to start with getting a good understanding of what a drag knife is. So let's have a look at that. I'll be cutting leather with a Donic drag knife on the CNC, and I've got one in the spindle now so you can understand how this works. Really critical that the spindle or router must be turned off when you use a drag knife. Now what's going to happen here is that when I spin this, that's bearings in the knife turning. That is not the spindle of the router or spindle of the spindle turning. I'm not turning the collet. This is on its own bearings. So when this is engaged with the leather and the gantry moves X, Y, or X and Y, this is trailing. And that's what's allowing it to make the cut. The fact that it can spin like this is going to allow it, when this creates a curve, it's going to track through that curve, cutting the leather. One of the things we have to know is different models are available. What's the deal with that? And there's some specs on this that you need to also understand. Donic currently makes a D1, D2, D3, D4. In my hot little hands, I have got a D3 and a D4. When you make your buying decision, what you need to do is look at this chart online, and the specs on this chart are going to tell you which of these units you need to get for your shop. There are variations in how thick a material the cutter will cut, and also variations in how tight a radius the different cutters will handle. The big difference from D1, D2 to D3, D4 is simply 1/4 inch collet versus 1/2 inch collet. In my case, both of my cutters work in 1/4 inch collets. When it's time to put a new blade in here, it's easy peasy. It comes with an Allen wrench. By loosening that screw, we can put a new utility knife blade in, and we're ready to go back to work. An important aspect of these to understand is that when we look at this, the tip of the knife is not in line with the center of the device, which means it's not in line with the center of your spindle. When you look at the chart and you see the number offset, this is what's referred to as the offset. The bottom line is how far is the tip of that knife behind the center axis of this mount. And it's a different number from the D3 to the D4. When you use the drag knife gadget, you're going to put that number in, and then, again, looking at the information on Donic's page, if you need to tweak and do some test cuts, you can change those settings in order to get better cut quality out of the work that you're doing. That's how these knives work. Now what we are ready to do is put them to work. Before you can use a drag knife to cut leather on your CNC, there are some things you got to do to get the machine ready. The spoilboard used with the drag knife needs to be dead flat. I install a sacrificial 3/4 inch MDF board over my T-track table. Measure the usable area of that board and create a pocket toolpath that size. Z0 your fly cutter to the new board and fly cut the new spoil board. I removed 30 thousandths of an inch from this one to get it dead flat. Carefully measure the thickness of your leather. Digital calipers are great for this. Turn your spindle or router off. Zero the drag knife to the new spoil board using paper as a feeler gauge. Lower the Z in tiny increments until the paper just drags under the knife. When you're ready to put leather onto your spoil board, we can't use the conventional hold downs. We need something that's going to secure it in the middle. And I've tried spray adhesive and that leaves stuff all over the leather that's really hard to clean up. Double face tape works really well for this. I'm positioning the tape less than an inch apart. I'd rather use too much tape and know for sure that it's not going to move than use not enough tape and have this thing wiggle as I'm cutting it. There's a little bit of lateral pressure from that drag knife, and it would be a shame if, with not enough tape on here, it buckled while it was being cut, and then you had to start all over again. This is always the hardest part for me. Yay! Now, make sure the spoil board doesn't have any dust on it. Give that a good push. Now the other problem we can run into is that these edges might roll up just a little bit, and I don't want to take the chance of those letting go. So this is kind of a belt and suspenders sort of an approach. I'm going to just use regular masking tape around the outside. And that's just to make sure that the edges don't start to peel a little bit. Ready to go. When you're ready to zero your X and Y axes, here's a couple tips for you. One, it's nice to have masking tape on the leather because I can put lines on the masking tape that are very easy to see. Lines on leather, one, you probably don't want lines on the leather because you can't sand them off. Two, they can be really difficult to see. So the masking tape helps a lot. The other thing that's weird here is that because of the offset in that drag knife, we can't just put the point over the XY center like you would if it was a V-bit. So here's what I'm going to do. I'm going to use my laptop here to manipulate the gantry and get that point over the center. But now, if I turn it, we're no longer centered. So I take a little bit different approach to the drag knife than I do with my regular cutting tools. What I'm going to do is turn it in the direction in which I am centering. So this is currently my X, so I've got the knife turned in the Y this way. Going to move it in the X until it's over the line. And what I like about this is really you can eyeball all the way down that knife to see alignment with the line. Now I'm going to move it to this direction. And then again, I'm going to spin the rudder there until it's lined up now in the X because I'm centering in the Y. Until that aligns with my center. So that way, by doing one axis at a time, we're getting the center of the drag knife over the center of the object. So it's an extra little step you have to take with a drag knife you wouldn't have to do with a router bit, but it's a way to get centered. The other way to play this is you've got some wiggle room. So if the offset is 0.16, which it is, then we've got, if the leather is 0.16 bigger than what we're cutting, you've got some room in the X and Y to make a little bit of a centering mistake. So if you really want to nail it down, do it the way I just did it here, or give yourself some room around the perimeter for your center to be off a little bit, the size of the offset, and you're going to be just fine. Before we create any tool paths with the drag knife, let's add a drag knife to the tool database. Pretty straightforward stuff here. We're going to go up here to Tool Paths, Tool Database. All we need to do is pick anything down here. I'm going to grab this 1/8 inch end mill, copy that, rename it, for a diameter here, it isn't, of course, a diameter that we're looking at, but we do want to assign a number here. And the reason is when we do a tool path and we preview the tool path, we want there to be some body to that thing so that we can see the work that we've done. We can see the tool path. So I am going to enter in here 0.03, 30,000ths of an inch. We don't have any flutes at all. Creating our settings here, we can, what it's by default doing on depth of cut is doing half the diameter, and we don't need to be limited to that. We can actually easily cut through 1/16 inch thick leather, so I'm going to change that to 0.06. For a spindle speed, we're of course going to not run the spindle. We need a number in there, so I would make the number really, really small so that if you forget to turn the spindle off and it does accidentally come on, it comes on really, really slowly. And a feed rate of 100 inches per minute is okay. That's all it takes. Now the drag knife is in the tool database and we can call on it as we start to create projects. Let's do a project that has a chance to pull at your heartstrings. Let's cut a heart out of leather. I've got a vector heart here, and the way I got that was by grabbing clip art off the web that was a JPEG. I used trace bitmap in order to turn that into vectors. For my material, I've got my X, I've got my Y, I've got my thickness. What's really critical in setup here is that we're Z0'd off the machine bed because, of course, that's where we zeroed the drag knife. On a shape like this, which is a pretty simple overall shape, we can also keep the tool path simple. Select your shape, go to Profile Tool Path here. We want to cut slightly through our material, so remember it was 0.08, so here 0.083. Then here in my tool database, I'm going to find and select my drag knife. And this is work we can do in a single pass. Now this is very important. With profile, we can cut outside, inside, or on. In this case, we want to cut right on that line. We don't need any of this. This is very important. What we do need is a lead. Think about the configuration of that drag knife. When it comes into the tool path, we don't know how it will be oriented because of its ability to spin. So using a lead is going to give it an opportunity to orient to the tool path before it actually starts cutting the tool path. So we do want to add a lead. 2-inch radius is fine, 1-inch length is fine. I like to name my tool paths based on the cutter I'm using. We're going to cut through. Yes, we are. Now, when we look at this, what this shows me is that the drag knife is going to start here and it's going to come in right on the bottom of that heart. And I don't think we're giving the drag knife a very good opportunity to work there. It's really not great to start it right on a corner, right on a sharp curve like this. So let's fix that. When we come back here, let's change to node edit. This green indicates our starting point. You can see the lead right there. We want to move that to some place where the line is a little bit straighter. So how about right there? What I did is I hovered, I touched P on the keyboard. Now my starting point is there. We can come over here and recalculate. And now we can see the lead is going to come in like this. So think about getting on a freeway. You're on the on-ramp, you're trying to merge. If you're merging into a sharp corner, that's going to be difficult to do. If you're merging into a long runway, like we've just introduced to the heart, it's going to be much easier. So now we can check our work. Now remember, when I put the drag knife in the tool database, I kind of randomly assigned it a width. This is why. When we do this, because the software sees it as having some dimension, the knife, I can double click my waist and make sure that this is what I want, that I'm getting what I want. So giving that drag knife just a little bit of dimension makes it look like a router bit, makes it look like a conventional cutter, so that we can really check our work here. So a consideration that we need to make is based on the size of these turns that the drag knife has to do. Clearly this curve is plenty big for the drag knife to handle. If you're doing a project where an internal curve like this is really, really tight, or even down here, if this point was really, really sharp, in that case, you would be better off using the drag knife gadget, because as you'll see, the gadget can compensate for those smaller radii or very, very tight points, very sharp points. It's very simple though in a case where the turns that the drag knife has to make are large enough for it to make. It's very simple to just do this with a profile toolpath and make our cuts. You need to look at the specs for the drag knife. The radius it's capable of turning is provided. So if your drawing fits within that, this is a simple way to do this. Here, we're going to be ready to go once we save our toolpath, go through the post processor, and from there, we can head out to the CNC and watch this get cut. Watch carefully at the beginning of the cut. Right here, there's our lead coming into the heart shape. From there, the drag knife easily navigates the big curve and handles that tight inside curve okay too, and of course, ends up right back where it started. Remove the masking tape, and your heart is ready to be set free. Let's use VCarve in order to set up this little project. It's a pouch. Inside the big pouch, there's a little pouch. There's a pocket inside there, and you can put a driver's license or a credit card or something in there. So here on the drawing, I have got my material set up, taken care of, the dimensions of my material, and again, Z-zeroing off the machine bed. We're good to go there. Now, one of the things we know about the drag knife is it's going to be happy to make these turns. All of that is good. It's not going to be so happy to make these sharp 90-degree corners. One workaround for that, of course, is to use the drag knife gadget, but we can again do this with a profile toolpath, but we got to add another element here. So let's take this and make a little bit of a change. What we know is that the drag knife's going to come to here, and if we're just running the profile toolpath, it's not going to be uber happy about making this turn, but let's take care of that. In Create Fillets, add this plasma drag knife fillet. So the way that works is when I click here and here, Now what's going to happen is when we come along with the drag knife, it's going to come out, turn, come back. Make this curve, come up here, out, turn, come back. So this is a great workaround because it provides a way in order for the knife to make that sharp corner, and we don't have to run the drag knife gadget if you don't want to. So again, we can use the profile toolpath to make all this happen. We've got our drag knife set. In this case, our material's a little thinner. We can do it in one pass, on the line. We're going to add leads. Going to call that a drag knife. There's our lead coming in. We're going to make that cut. There's our lead coming in. We're going to sweep around. Sweep around. There's our lead coming in. So I'm happy with the way these leads are entering the material, entering the project in every case. That means we can go cut this. Watch the drag knife enter the workspace, and as it gets to that first sharp outside corner, it takes advantage of the drag knife fillet that we added to the toolpath. That fillet provides such a simple way to get sharp outside corners on your leather projects. As the drag knife comes into the next component, watch for the lead right there. And then again, we're back to turning corners with those fillets. In real time, we're cutting at 100 inches per minute, but I've sped up the video just to move things along a little bit for us. Remove the masking tape and you're ready to peel your pouch parts up off of the spoil board. Because of the offset on the drag knife, look right there, it doesn't quite finish the cut. It doesn't quite come back to where it started. I find this to not be a big deal, and I just clean up that little bit of tab of leather that's left there with a utility knife. That gives us the back of the pouch, a little inside pocket that'll hold your driver's license or credit card, and the front of the pouch, once I peel that double-faced tape off of it. And I never reuse double-faced tape. I put new stuff down every project. Let's have a look at using VCarve Pro in order to cut some pretty heavy leather, make a knife sheath out of it, and do that using the drag knife gadget. I've got my sheath shapes already defined here, and in our setup, this is pretty standard stuff. I've got the size of the material, the thickness of the material. Going to talk more about that in a little bit. Most importantly, we're Z0'd off the machine bed. XY zeroed in the center of my material. Now, one of the things I have found is that it's easiest to work with these if I do one at a time instead of toolpath them both at the same time. So select one, gadgets, drag knife. By default, this depth is your thickness of material. I'm going to increase that just a little bit. Add 0.02 to that just to make sure the knife cuts all the way through. This swivel depth, here's the deal with this. When this knife, when our drag knife comes to a corner, a sharp corner, it recognizes it can't just turn the corner. So what it's going to do is it's going to lift out of the material just a little bit, initiate the turn, and then go back in to depth of cut. So what this number is how much of the tip of the knife remains engaged in the leather when it initiates that turn. 0.07 is working well for this project. You can mess with this number. You're going to have to do some experimentation to see what works for you, your machine, the leather that you're working with, but we need just a little bit of the tip engaged. When you see this cut happen in a little bit here, this is going to make more sense to you. Because of the thickness of this material, I like doing this in 2 passes. We are going to use vector starting points. Blade offset. That blade offset is important. It's a number given to you by Donic. All we need to do is go back to the Donic website, find our particular tool, and look here for the offset. Now, here, one of the things they tell you is that the offset values are approximate. You might have to mess with that number a little bit. And they tell you the symptoms to look for. If it's doing this, increase the offset. If it's doing this, decrease the offset. So you might have to fine tune that a little bit as you go. We can take that number back to VCarve, enter it here. Tolerance angle. That's telling the gadget at what point do we want to use that lift, turn, cut, rather than just making a turn. So 20 degrees is a good starting point there, and again, a little bit of experimentation. You might fine tune that, but 20 degrees is a great starting point. From there, we can OK. And what we've now got here is a drag knife tool path for this. But I want to check something. And in order to really check it, what I want to do is go into Node Edit. That green tells me the starting point. That's true for any tool path. When I zoom way in, this is showing me that the drag knife is going to start out here, engage with the work, and then move. That's what I need to double check. I need to make sure that it's starting on the outside, then coming in. That's the waste side. Not starting here where I have parts I want to keep. I don't want a knife cut in the sheath. So let's do the same thing up here. We're in Node Edit. That shows up as my starting point. Same deal here, drag knife tool path. I'm going to add 2/1000ths. All the other parameters remain the same. Now, when we look at this, well, this is cool. Again, we're starting on the outside. Let's mess with this just a little bit and see if I delete that tool path, come back here, hit P, and see how that just turned green when I keyboarded the P. Now that's my starting point. So now, if I go to drag knife tool path, do all the same stuff again, and zoom way in. So now, look at that. My drag knife is starting in the work. It's starting in the part I want to keep. That's no good. So examining that, you want to really zoom way in like that and see what your starting point is. I'm going to go back here, make that my starting point, delete that tool path. Because we're using an imported tool path with that drag knife gadget, you can't just recalculate. We're going to delete and then reinitiate through the gadget a new drag knife tool path. So back to gadgets, drag knife tool path. And then when we come here and do a double check, boom, got it. So what I have found with individual components, with a bunch of stuff to cut out of the leather, it's easier for me to work on that one component at a time, work on it being getting the starting point right, getting this initiated so the drag knife is on the waste side of the work. It's easier to do that when I select one, tool path one, select another one, tool path another. But the beauty of VCarve is that because these tool paths have been done with the same tool, the drag knife, here I can save them, I can export them to the machine in one file. So by checking this, both of these tool paths are going to go together. I've got the post processor for the ShopBot picked. So when I save that, it's going to stack those up and they're going to run back to back to back to back on the CNC. So that takes care of the software side of this. Let's go look at the hardware side. Let's have a look at this tool path running on our CNC machine. The drag knife enters the workspace, and then watch on these corners a little uplift, turn, uplift, turn. Watch here in slow-mo where you can really see uplift, turn, re-entry, uplift, turn, re-entry. That's how the gadget makes those sharp corners. I've again sped the video up just to move things along, but if you watch close, you can still see it making those subtle lifts and turns to get sharp corners. Let's take away everything that doesn't look like a knife sheath. And see what we've got. This is some really thick and stiff leather, and man, the drag knife did a great job cutting it to shape. And yep, I made that knife. Let's bring it all together and add one more new element in this project. This is a desk valet, so when this is done and cut out, these tabs are going to fold up against these sides and rivets are going to go through these holes in order to hold everything together. It won't surprise you to learn. I've got my material all set up here. Now notice that we're back to a thicker leather again, so that's going to come into play for us in a little bit. And let's keep this simple and go with a profile toolpath like we've done before. Now in this case, we again want to overcut that just a little bit to make sure that we go all the way through. And we're going to do this in 2 passes. With this heavy leather, I just find that we get better cut quality. Even though we've got this stuff double face taped to the spoil board, if we lighten the load, if we do it in 2 passes, there's less chance of that leather skating, getting pushed sideways as we're cutting on it. So let's keep it simple and do it in 2 passes. Cutting on, don't need ramps, but we do need a lead. We're going to drag knife it. And this works out well, like we've talked about. We've got our lead coming in here on a long straight, so that's going to make it nice and easy for the drag knife to engage and get started there. And of course, node editing would allow you to move that lead wherever you wanted it to move. Now, one of the things that's letting us get away with what we're doing here is that when this was designed, it was created in a way that these radii fit within the parameter of the D4 knife. So part of your design consideration when you're going to work with leather is if you want to do profile toolpath, it's such a simple way to set this up. Just make sure that the radiuses, the radii that you're using, work with whatever drag knife you're using, and then you can do everything with just your standard profile toolpath. That takes care of what we're going to do with the drag knife. Now, what are we going to do about these little rivet holes? Well, just to show you that you can use your conventional router bits on leather, here we go. Select. Go to the drilling tool path. Set your cut depth so it slightly exceeds the material thickness. We're going to do this with an 1/8 inch end mill. We are going to peck. And as always, I like to call the tool path the bit I'm using. And you'll see in just a little bit on the CNC just how well that router bit does to drill those holes for us in the leather. Let's preview. Here's what we get. Double click the waist. And there is our desk valet or our tray ready to be cut. Watch as the drag knife starts the cut. We're going to see a lead again right there. And then it starts pivoting through those relatively tight radii that this project has. I think it is so much fun to watch the drag knife do its thing on leather. Now again, I've sped the video up here. Real speed is 100 inches a minute. Fairly thick stuff. So I'm doing this in 2 passes, as we saw in the toolpath. I've installed an 1/8 inch upcut spiral router bit and Z0 that to the spoil board. And now we're ready for the boring part of this project. Drilling 1/8 inch holes like I'm doing here is the only application I've used a conventional router bit for in leather. Let's have a look at what we've got. Very cool, and a great example of the curves we can cut in leather. I brought it together by transferring the holes we made with the router bit into the adjacent face and adding rivets. One of the things I love about working with CNCs, learning about CNCs, is the expanding arena of what they're capable of. This is such a great example. Yeah, we can cut wood, non-ferrous metal, plexiglass, can etch glass, can etch metal, can cut leather, and being able to combine doing those drawings in CAD, the precision of the machine. This particular project, my favorite from this, is such a great example of that. In order to be able to turn the corner and do those intricate cuts that were needed to get the bends in this so that everything could be riveted together, it's a great example of why you would learn to cut leather on your CNC. So I love doing this. I hope you enjoyed this session, and I look forward to have an opportunity to teach you again sometime.